Okay, welcome everybody to Standing for Truth. My name is Donnie Badinsky. I am your host for today's program. And as always, I am thrilled to have Michael J. Ord with me for another valuable presentation. Mike is an excellent researcher and has blessed us here at the ministry with so many great presentations. These presentations, which you can find in the description box of this video, you can also find them on the Standing for Truth website, standingfortruthministries.com. And these presentations include the receding floodwaters, always very comprehensive, the Ice Age, answering challenges and refuting objections, the Green River Formation, the Grand Canyon, flood boundaries, and more. Now, today's program will specifically focus on the rapid formation of caves and speleothems. Like all of Mike's presentations, I am excited for this one as the formation of caves in a young Earth timescale is a major objection raised by the critics. And so I am excited for this. Before I hand it to Mike, though, for his presentation, I do want to give him a formal introduction for anybody unfamiliar with Mike. Michael has a master's science degree in atmospheric science from the University of Washington and is now retired after working as a meteorologist with the U.S. National Weather Service for 30 years. He has researched and speaks on the compelling evidence for Noah's flood and the ice age that followed, and how the incredible woolly mammoth connects to biblical history. Michael has published many papers in his field in widely recognized journals and has written An Ice Age Caused by the Genesis Flood, Ancient Ice Ages or Gigantic Submarine Landslides, the Missoula Flood Controversy and the Genesis Flood, and the Frozen Record. He is also author of Frozen in Time, The Weather Book, and Life in the Great Ice Age. Also behind me, if I'm not mistaken, Mike's newest book, which I highly recommend, Biblical Geology 101. And so, Mike, again, brother, it's great to have you. How are you doing today?
Very well, thank you.
Great. I'm looking forward to this. Before I hand it to you, I'll let the audience know, as we typically do with these shows, we are live. And so if you do have a question on tonight's topic or just the flood, young Earth creation in general, please make sure to send those in. Tag me either at Donnie or at Standing for Truth, and I will save those for after Mike's presentation. And so, Mike, I am going to get your slides up on the screen, and the floor is all yours.
Okay. Well, today I'm going to talk about the rapid formation of caves and speleothems. Anyway, young Earth creations have a lot of challenges. Since I try to keep up with 50 earth science journals in the Montana State University Library here in Bozeman, Montana, I come across them all the time. Here's just a quick list off the top of my head. How does the flood cover Mount Everest? How do sedimentary layers form? Origin of angular unconformities, etc. Here's a continuation of it. And one of these is the Yellowstone fossil forest, which I'm going to kind of showcase before I start. But I want to take a closer look at challenges. First of all, we have this many challenges because there's not enough creation science researchers. Also, there's numerous unknowns in the sciences. But we do have answers to many challenges. Many of these, I find out, are challenges to uniformitarian geology. And I'll try to point out some of those challenges in this talk. Some challenges are easy, some take a long effort. Some may take 50 years. But we cannot solve all challenges. That's where we have faith that enters in, that we can answer enough that we can have trust in God's word, the Bible. And of course, this is my theme verse for research. 1 Thessalonians 5:21. Examine everything carefully. Hold fast that which is good. I'm holding fast the Bible as God's word. But from then on, I examine everything carefully. I can't emphasize that word carefully enough. If you don't dig deep, a lot of times you might know just enough to get in trouble. So you got to dig deep. And when we do, a lot of times we find answers to these challenges. So we do have answers. Here's just a quick list, which I have worked on. How the floodwaters cover Mount Everest. Well, you don't have to bring the oceans up to cover the present mountains. The mountains, with a lot of times with marine fossils in the top strata, they rose up out of the floodwaters to drain the floodwaters. Early flood dinosaur tracks and eggs. With my beds model, we can account for those, or at least it's a pretty good hypothesis. Supposed windblown sandstones, we have a lot of those in the western U.S. here, but when you look at them in detail, like Dr. John Whitmore has, you find out, first of all, there's many challenges of the secular view of these things as windblown, and then you find features that indicate they were water-laid. Origin of large-scale planation surfaces is another one which I have worked on in the fields of geomorphology. Origin of water and wind gaps, origin of the Ice Age, and the Yellowstone so-called fossil forests. So I'm going to quickly talk about this challenges as an example because it's brought up a lot. And so here it's only about an hour and a half from my house. So I've been there, these places, quite a few times. But here's some vertical trees. You see at the top of what's called Specimen Ridge. Notice the material that it's in. It's in breccia, volcanic breccia. Very angular, as I'll show you more pictures. They're petrified. When we were up there one time, it looked like some of the wood in these things was not petrified, or at least it was not permineralized a lot, or it was not at all or lightly. It's hard to tell without an analysis. So anyway, here's kind of a cutout that many people see. They believe it's a series of forests grew for 500 years, overwhelmed by a volcanic debris flow, and then had to wait for another 500 years, grew again. And so every one of these layers you see here of fossil trees, mostly vertical, a lot of them horizontal, represents about 1,000 years. And so on Specimen Ridge, I think there's about approximately 25 levels. And there's another location called Specimen Creek, which has nothing to do with Specimen Ridge. And it has 65 levels. So that'd be 65,000 years, supposedly all that was formed. But when you look closer, you find lots of problems. Here's a picture of Specimen Creek. And you can see some of the fossil trees. Some are at an angle. So this is one location. It's quite dangerous. I used to guide people up there, but then when I realized how dangerous it was, I'm not doing that again. Anyway, this is the material that it's formed in. It's in what's called the Absaroka volcanics, which are layer after layer of volcanic debris flows, a lahar or breccia. Sometimes there are actually flows of basalt, and sometimes there's ash layers. And it's been greatly eroded after it was formed. It was deposited over an area of 9,000 square kilometers, and it was about 2,000 meters deep, layer after layer formed over that huge area. And that's where the vertical trees are in a number of places. You can see isolated trees too in this. And what it looks like on the ground is that. It's difficult to imagine a forest growing in that stuff. Volcanic breccia. And here's some challenging observations for the uniformitarians, the skeptics that are listening to this or going to view it later. First of all, you don't have any soils. Trees need soils. You have organic layers, and in the organic layers, you find fossil leaves and needles, but they're not decayed. So it's just a leaf litter that's been quickly buried. No soils. Big problem. And when you look at the types of tree from the pollen and analysis of the trees, there's 200 species of trees from the tropics to the cool temperate, all in one area, which makes no sense, even though I know that skeptics have suggested ways to avoid that. And a man from Loma Linda University did a master's and a PhD matching the rings from 3 levels, indicating that there weren't separate forests over 1,000 years, but they were the same forest deposited in 3 different layers. Also, there's no animal fossils, which is another strange feature. Anyway, that's a challenging. And then when Mount St. Helens went off in 1980 and Spirit Lake collected hundreds of thousands of logs, we have an analog for explaining the Yellowstone fossil forest. A lot of these trees were vertical, were floating vertical, and they sank vertically as the bottom was forming sediment, kind of like this right here. And this brings up another issue with there's a lot of vertical trees around the earth. I've seen probably a dozen locations. Here's one in Tennessee. Notice no roots or soil, which would indicate the log mat model dropping trees vertically as sediments forming. Here is Fluorescent National Monument in Colorado. These are redwood trees up to 4 meters in diameter. They're up to about 700 years old based on the rings. Or anyway, it has no soil or roots. Anyway, this is typical of areas with that are paleoflora sites. Also, Harold Coffin noticed one polystrate tree upside down, indicating again that we can account for not only the Yellowstone fossil forests, but vertical trees by the log mat model. And here's a brief kind of a schematic of this. Here's the log mat floating in what is now the Yellowstone Park area. And the bottom is being deposited with volcanic debris, and logs are sinking vertically. And as in the debris flows one after another, like that. So I think that's a good model. And I can thank the late Dr. Harold Coffin for this information. A good friend of mine, by the way. So let's get to the cave challenge. With that as kind of an introduction, here's a challenge. Arthur Strahler, a well-known anti-creationist, in his well-known book, Science and Earth History, says this: if it can be shown that either the excavation of caverns or their subsequent filling must require a vastly longer time to accomplish than the post-flood limit, literal acceptance of the Genesis chronology is untenable. We turn first to rates of removal of limestone by the process of carbonic acid reaction. Yeah, he would believe, and most of the older geologists would believe, that the caves were formed by carbonic acid reactions, which is it's a very slow process. Of course, it takes millions of years to form a cave, but there's lots of problems with this idea. But first of all, before we get into those problems, let's talk about the speleothems. Speleothem is a general term for the cave features. There's stalactites that hang tight to the ceiling, stalagmites that grow up from the bottom, columns where they join, and flowstone. which is calcium carbonate that flows from the walls or the bottom. Those are the type of speleothems. And here's a few pictures. There's some small stalactites. Think of them as hanging tight to the ceiling. Here's a large stalagmite. And here's a column. I think this is from Luray Caverns in Virginia. And here's flowstone. So let's get back to some challenges for the uniformitarians. The formation by carbonic acid, there's some really big problems. Anyway, the carbonic acid is formed in the soil from water and carbon dioxide, and it seeps down into the carbonate. It's a weak acid, and it seeps down through the cracks in the rocks. But that acid is neutralized almost immediately as it sinks down. Some reports say within 1 meter, some say up to 10 meters. And so it's no longer can form an opening. It can't form a cave. So this is a huge problem. Also, the carbonate rocks that they're found in are too old, but the caves are young. Why didn't the caves form soon after the carbonate was deposited? Well, they could probably, skeptics could probably say, well, it's because it didn't uplift and crack. I'll get to that more later. And speleothems are not millions of years old. They're now considered too young. They're with formation rates of 0.1 to 3 millimeters a year on top of a stalagmite that's growing up like this. Also, you can show the cave opening formed first, and then the speleothems. The opening is where you dissolve the limestone. Speleothems are where you deposit limestone, just the opposite. I'll get into this a little more detail. Because of quick neutralization, they believe caves formed at shallow depths. But that's a problem, even at shallow depths. And many caves are deeper, over 1,000 meters deep. So the uniformitarian scientists have the same problem of forming caves as us creation scientists. So here's a quote to back up a little what I said. In the great book, Cave Minerals of the World by Hill and Forte, they said this is what they often hear. A large stalactite or stalagmite takes millions of years to form. But this is what they say. Caves take more likely only tens to hundreds of thousands of years. So they can form quickly within the uniformitarian timescale. That's greatly slower than the creation science timescale. So there's when forming caves, there's two cave challenges for creation scientists and uniformitarian scientists. First of all, you got to form the cave opening, and it appears that was formed first. And then you have the problem of the origin of the speleothems that decorate the caves. They don't occur simultaneously, by the way, or you'd have a real chaos of dissolution features and deposition features. It'd be a mess in a cave. So I'll divide these up into two, the origin of the cave opening and the origin of the speleothems. Here's a cave opening. Some may recognize this. This is Carlsbad Caverns, of course. It's in the Guadalupe Mountains of New Mexico. There are over 300 caves in the Guadalupe Mountains. Carlsbad Caverns is not the largest. Lechagula Cave is probably the largest. And they won't let you go into a lot of these caves. But anyway, you go into Carlsbad Caverns. And here's some stats on it first. The limestone is 250 million years old, but the caves only started 4 million years ago. Should ask, well, why didn't they start soon after the limestone was hardened? Also, in Carlsbad Caverns and most of the Guadalupe Mountain caves, speleothems are rarely growing today. Why? Because it's too dry. The climate's too dry, and the climate is a major factor in forming speleothems. That might give you a hint that maybe during the Ice Age, the climate was different, that they can form faster, but I don't want to get ahead of myself. Also, the soils in that semi-arid area are too thin, and it takes soil to form speleothems and little vegetation in those areas. But they made a discovery in Carlsbad Caverns, and since then, other caves started in Carlsbad Caverns, or wait a sec, there's other reports, but mainly Carlsbad Caverns, that sulfuric acid dissolved the carbonate. Now that brings up a lot more potential for rapid formation of the openings, does it not? Anyway, they thought quite a while ago that 10% of caves were what's called hypogenic. That means formed by sulfuric acid or some other acid. It's possible that other acids can form the cave openings too. And now believed that more than 50% of caves are hypogenic, formed by sulfuric acid. And that's a totally different paradigm. And what's some of the evidence? Well, when sulfuric acid reacts with carbonate, it forms gypsum and a lot of other types of minerals that you find in these caves. Like in Carlsbad, here's massive gypsum. And here's the picture I took. About 4 meters thick of gypsum in the big room of Carlsbad Caverns, formed by sulfuric acid deposition. So it was pretty easy to come to the conclusion that this cave, Carlsbad Caverns, was formed by dissolution by sulfuric acid. And so here's a quote from an expert, Klimchuk and Palmer. They're both experts on caves. And it's from a pretty thick book, Hypogene Karst Regions and Caves of the World. It was over 700 pages. It says, more attention to hypogene karst since 1990, and particularly the dramatic burst of studies in the field during the last decade, has changed our notion of hypogene karst from a curiosity to one of the fundamental categories of karst, at least of compatible importance with more familiar epigene karst. That's the belief that karst was formed by carbonic acid. He goes on, hence the potential for the development of hypogene karst is immense, not only in the continental domain, but also in the ocean domain. Moreover, even in Europe and North America, many areas have been recognized only recently to host hypogene karst, and its study is still ongoing. This means that the next editions or volumes under this title will be needed. This phenomenon, hypogene karst, can be globally even more widespread than epigene karst. More than 50% of caves. And, a lot of caves don't have the depositional, or the chemical features from carbonic acid, calcium carbonate and sulfuric acid reactions. And that doesn't mean it didn't form by a hypogene mechanism, but that it could have all this material been washed out. So it's possible that all caves are formed that way. So in summary of this section, likely all caves formed by sulfuric acid dissolution. Dissolution products may not necessarily be present. Thus, cave openings can be formed rapidly, can form during the uplift and dewatering and decay of organic matter during the flood. Anyway, the flood can be graphed in 2 stages, a flooding stage and a retreating stage over 371 days. During the flood stage, you form the sediments. In the retreating stage, you erode the top of the sediments as the waters run off the continents. As the continents came up and the ocean basin sank relative to each other. So here's a schematic of this. Anyway, limestone comes out of solution in water, deposited, and other sediments are formed on it. And then you start uplifting to drain the floodwaters. And as you uplift, you expand. And so weak bedding planes, joints, which are cracks in the rocks, open up a little and allow water to come in there. Sulfuric acid coming in. Once you get that opening more than 5 centimeters, then it's almost turbulent flow through the limestone. And you can excavate caves very fast like this. And this is what you'd end up with. And notice I formed a flat surface on the carbonate. I'm going to revisit that because that's the case in the Guadalupe Mountains, where you have a planation surface at the tops of the mountains that has been dissected. And I'll talk more about that as we go. So you can form the cave openings in the flood rapidly by the uplift of the limestone and the cracking of it and the excavation by sulfuric acid. So the Guadalupe Mountains have a mountaintop dissected planation surface. This was, you can find this article by J. Harlan Brett's Journal of Geology. Brett's, of course, is from Lake Missoula fame. He discovered that, and this is to be a flood feature by the planing first during the wide currents flowing off the earth, and then dissecting as the flood channelizes. So it's the flood water running off becomes more channelized. That's when you form water and wind gaps, by the way. So you can dissect, form valleys and canyons rapidly in this model. Anyway, he found out that the valleys that formed during the flood cut through caves that were already there. Also, some caves start on narrow ridges. What's the significance of that? Well, it takes soil, thick soil, to form the carbonic acid to filter down into the caves that form the speleothems. And you don't have that on a ridge, so the cave can't form. So it formed before, and that's why caves in the Guadalupe Mountains do not conform to the topography. They're formed before the topography was formed. And as far as getting sulfuric acid in the sediments, during the flood, you had much decaying organic matter in the sediments. There's a huge amount of organic matter in sediments, like some limestones are gray. That's because of organic matter, and some are black because of so much organic matter. Also, decay of organic matter forms hydrogen sulfide. When you combine that with oxygen and water, you get sulfuric acid. Also, you find evidence of rapid flows through the caves. Cobbles and boulders and wall scours are evidence of rapid flow of acidic water. So we can account for the origin of the caves by the flood. How about the origin of the speleothems? Going from dissolving the calcium carbonate to now depositing calcium carbonate in the opening. Well, Hill and Forte in their magnificent book, Cave Minerals of the World, say, quote, how fast do speleothems grow? We cannot predict a rate for a particular speleothem, but on the average, calcite travertine on the speleothem, that's another name for the calcium carbonate, grows about 1 millimeter or 2 a year. And that's pretty fast. Emil Silvestru, who wrote a book on caves and articles, and this is from Creation magazine. He says, now let's consider one of the tallest stalagmites in the world in the cave Armand in France, shown above. At 3 millimeters per year, which would be pretty fast, it would have reached its present 38 meters in 12,700 years. Clearly, this contradicts the ages of hundreds of thousands of years obtained from radiometric dating. Yeah, that's a maximum of that's assuming present processes, of course. But remember, in our model, we don't assume present processes. We have mechanisms for catastrophic processes. And when you read the literature, you read some pretty fast growth rates. These are extremes, I'll say. Some stalagmites in Belgium, 2.7 to 4.3 millimeters a year. A growth ring in southern Siberia was discovered to grow 15 millimeters a year. A man named Shaw listed 25 rates that averaged 3.7 millimeters a year. There's a Yorkshire cave, northern England, that grew at 7.3 millimeters per year. And a lead mine in Iowa at 300 millimeters per year for 3 years. That's fantastic. I had to look that up, and I did. And it's in the literature. Even Hill and Forte use it as a valid measurement. So even at today's rates, speleothems can grow rapidly. Okay, what are the ways you grow speleothems? Now, this is quite complicated and depends on many variables, but there are mainly 5 main variables, with the 6th being one that is rare, but because most caves have 100% relative humidity. But if the cave did not have 100% relativity, the evaporation of water can produce the calcium carbonate speleothems. But I'll talk a little bit about one of these in turn. The main variable is the concentration of the calcium ion in drip water. And I'll get into that. And that depends on other variables, which depend on other variables. See, this can get really complicated. First of all, you have to form from carbon dioxide that forms in the soil. It's got to be absorbed in the water of the soil, and that forms carbonic acid. And that depends upon tree roots and soil respiration. In other words, if you have thick soil, lots of trees, you have a lot of soil respiration, a lot of carbonate in the soils. And by the way, the partial pressures of the carbonate in the soils can get up to over 100 times that of the atmosphere. I mean, it's really a lot of carbon dioxide. And it depends on the quality and quantity of the soil organic matter. Microbes working on the soil organic matter give off the CO2. And that depends especially on soil temperature, thickness, and moisture. Thicker soils would have more carbon dioxide, warmer temperatures, more carbon dioxide, more moisture. But it's not a linear relationship. It's more like if you have too high temperatures, it thwarts the formation of carbon dioxide. Too moist and it thwarts it. But so you got to have a happy medium. And also, as you form the carbonic acid in soil, it seeps down through the carbonates and reacts with the calcium and forms neutralizes, of course, and you form a calcium carbonate, calcium and carbonate ions, and the flow path going down into the limestone is variable. So here's a little schematic, lots of precipitation, tree roots, soil organic matter forming a lot of carbon dioxide. It seeps down through the carbonate. The top 15 to 30 meters is called the epikarst. Then you get into what's called the vadose zone, which is generally, that's where there's air in the cracks. Then you get to the phreatic zone down below, which is flooded. That's below the water table. And so it comes down in various pathways and forms the speleothems. And it can come fast after a rainstorm or very slow as it kind of meanders around through the carbonate. So the flow path is just quite variable. And then they drip, forming the stalactites and stalagmites. Anyway, to form the stalagmites and tights, as the water enters the cave, it has a lot of calcium carbonate. The more calcium and the carbonate ions are in ions because they're in water. And the more the calcium, the faster the speleothems grow. And it depends on the forming carbon dioxide in the air, how fast it moves out of the water. And this is the rate limiting factor of forming caves this way, because it's a slow process. The other reactions are fast. So as the carbon dioxide leaves, it plasters on the calcium carbonate on the speleothems. And here's kind of an image of the top. They think that the water layer averages about 0.1 millimeter. And as it's on the top of the stalagmite, it's kind of a slow flow. And because of that, it has a boundary layer. And the boundary layer will have kinetic effects that inhibit the formation of calcium carbonate. As you see in this blow up right here. I'll get into that a little more. So as you see, the variable, the amount of calcium ion in the drip water is one main variable. Secondly, the cave CO2. How much CO2 is there? If there's a lot of CO2, it doesn't degas very fast. So if you can ventilate the cave fairly well, then you can degas the CO2 fairly fast. And so the ventilation of the cave is another variable that will change the cave CO2. And here's a little schematic in Carlsbad. There's several ways to vent caves by different temperatures, and wind and storms will cause more ventilation. So a lot of times the cooler air will sink into it and the warmer air will exit out. And it'll decrease the carbon dioxide of the air. And the more it decreases it, the faster the degassing and the faster the calcium carbonate forms on the speleothem. Big factor. And this is where the model of the flood can help us, because cave temperatures now are adapted to the present average climate. But at the end of the flood, cave temperatures were probably much warmer than they are today. The warmer the temperatures, the faster the calcium carbonate forms the speleothems. So some possible flood aftermaths, that there would be a lot of sediments left over with high organic content. As the floodwaters ran off, the last bit left on would probably be mud in a lot of places. Also, the rock would be very warm. Well, how was that? Well, I've discovered, based on what's called the GlobeSed project, the results published in the journal GQ, which stands for Geochemistry, Geophysics, Geosystems, reported on the amount of sediments in the ocean. And based on that, we can determine that the average erosion during the recessive stage of the flood was 1,900 meters. So if you erode the top 1,900 meters of the sediment, and the temperature is warm with depth, the surface of the earth or in caves would have warmer temperatures than today. And that would greatly aid the formation of speleothems. And by the way, this erosion, that's an average. I've actually calculated it for 5 areas of the world. And one of them was in the Northwest Colorado Plateau, where I got an average erosion of about 5,000 meters. But secular scientists, from an article by Schmidt in the Geomorphology Journal, Earth's Surface Processes and Landforms in 1989, said that the average erosion of the Colorado Plateau is 2,500 to 5,000 meters. Think of that. That's the average for that whole 130,000 square mile plateau in the southwest U.S. But then I might ask, if it was slow erosion, according to the uniformitarian principle, where's all the erosional debris? The erosional debris isn't there and it isn't nearby in some monstrous floodplain or a whole bunch of floodplain. It's gone. So this seems like a uniformitarian problem. Where did the debris go? Where is it? I believe it's along the continental shelf, forming the thick continental shelves that we find along much of the continents. Some of those shelves have sediment thicknesses of 15,000 meters. So we had a lot of erosion. So the leftover temperatures would be warm. In fact, this is called the Cave of the Swords in Mexico. Those are gypsum crystals. And you can see the man for scale. These are 12 meters long, 4 meters wide, weighing 55 tons of gypsum. And they're able to determine the temperature of growth depending upon fluid inclusions at about 47 to 54 degrees centigrade, indicating that they grew and the temperature was much warmer. And this would go along with the flood eroding, leaving temperatures much warmer than today. And they'd be cooling with time, of course, by conduction and convection. So I talked about the concentration of calcium ion in the drip water, the cave carbon dioxide, which you need to excavate or ventilate fast, and cave temperatures. Now the drip water flow rate. And from Hill and Forte, they say in rapid column growth that the faster the drip rate, the faster the speleoforms form. Typically, and they're talking about columns that join. These are the most challenging of all cave features for creation scientists to explain. Typically, the largest columns are aligned along ceiling joints. These are cracks in the ceiling, where the greatest amount of water is dripping into a cave. Hill, 1978, correlated the location of the most massive columns and stalagmites in Ugo Cave, New Mexico. It's one of those Guadalupe Mountains caves, with valleys on the surface that overlying the cave. So think about this. Let's finish the quote. The joint along which the valley had developed is the same as that along which the massive travertine developed. In other words, the columns are above valleys with joints. So you have a fast drip rate. And during the flood, you'd expect mud with a lot of organic matter to be caught in pockets, little valleys. And so you can have a high organic content of the soil within that valley. And so the combination of would cause rapid formation of speleothems. And it also depends on the drip rate. If the drip rate is more, you have faster runoff of the waters and it becomes more turbulent. And turbulent water will deposit calcium carbonate much faster than in laminar flow, smooth flow. In fact, that's why flow stones in caves form quickly and very thick, because they're generally formed by turbulent flow of the water. So when you put all these variables together, early in the mid-ice age, you'd have tremendous potential to form speleothems rapidly. Why? Because in the ice age, at the beginning, you had mild winters and much more precipitation. So you'd have thicker soils and result in a higher drip rate, water, calcium, ion. And like I said, you'd have very warm cave temperatures, low cave CO2. With the warm temperatures and the colder temperatures in the air, you'd have rapid ventilation of the caves, taking out a lot of the CO2, much higher drip rate, thicker water film. And as far as the relative humidity, water evaporates also, so the relative humidity of caves is near 100%, but some caves, it's lower, and so it's possible that you can form some speleothem calcium carbonate by evaporation. So here's kind of a schematic of the ice age based on warmer oceans, and the warmer oceans cause warmer winters, by the way, and the volcanism causes the cooler summers, so you have very little seasonal contrast, which is actually verified by disharmonious associations during the ice age, where you have animals and plants that love the cold next to animals that love the warmth together. And this is not an exception. This is the rule of the ice age. So this is kind of a quick schematic of the ice age. Rapid evaporation because of the warmer water, volcanic dust in the upper atmosphere reflecting some sunlight back to space, and a rapid dump of snow and ice in the cold land. And here is postulated temperatures that I did. You can see the average, look at the red and the blue line, the average summer temperature and the average winter temperature. This is for the Northern Hemisphere. At the beginning of the ice age, winters would be warmer because of the effect of the warmer ocean. But summers would be cooler, so there'd be little seasonal contrast. But as time goes on, the summers will warm and the winters will cool. In fact, towards the end of the ice age, winters become even much colder than today. Also, because of all the rapid evaporation with the warm water, you'd have a lot more precipitation. So here's kind of a curve with the ice age, a time going to the right. You'd have a lot more precipitation, but by the end of the ice age, you'd have a lot less precipitation. So you'd have a lot of droughts, dry weather, very windy. Of course, this all caused the extinctions of 2/3 of the mammals over 100 pounds globally. So, can we estimate the magnitude of these variables? Well, I tried to do this, and here's what I got. Equitable temperatures and more moisture during the ice age, causing more soil carbon dioxide, more calcium. I estimated that it enhanced the growth rate maybe 1.5 to 3 times over today. Thicker soil and more vegetation, 1.5 to 3 times. Higher cave temperatures, the same. Greater ventilation of the carbon dioxide, the same. Much faster drip rate. I believe that would be a more significant factor, so I estimated 2 to 6 times. Thicker water film, 1.5 to 3 times. So when you add all those up, the speleothems can grow up to maybe about 100 times faster than today, early and mid-ice age. Further research questions I have is the dating of the speleothems, mainly by uranium series methods. And there's a question, can oxygen and carbon isotopes tell us the past climate? I think there's a lot of questions on this. For one thing, there's way too many variables in all this. And it's hopefully will be the subject of a future paper dealing with caves. In summary, challenges often can be solved by holding to the Bible. Hold fast that which is good. 1 Thessalonians 5:21. Cave openings are formed by sulfuric acid dissolution during flood runoff. Speleothems grow rapidly during the Ice Age, well over 100 times present rates in many areas. So you can form caves and speleothems rapidly by the flood and the Ice Age. And that's all I have. Thank you.
Mike, thank you as always for a comprehensive and technical presentation on an important topic, the rapid formation of caves, which, as you've pointed out, is a major challenge to young Earth creationists.
Yeah.
And I appreciate how, as you usually do in your presentations, you started off by addressing some of the other challenges like Specimen Ridge, but then showcased how the purported challenges to young Earth creationists, the uniformitarians or evolutionists, they have their own challenges associated with those.
They do. And a lot of skeptics don't know about them. And a lot of times, if you go to a university, get a bachelor's degree in something like geology, you might not find out about them.
Right.
You got to do some research to find out their problems too.
Are these problems that they are essentially admitting to in the conventional literature? That
some are, like in the book Hill and 40, they admitted that they don't show millions of years. To them, in their time scale, they show tens to hundreds of thousands of years to form the speleothems. So sometimes you find it in the literature, sometimes you don't. You figure it out yourself.
with an example like Specimen Ridge, you listed off several challenges for them. Are those challenges that you find they are at least attempting to address or largely ignoring them?
I think they're largely ignoring them in that case, because I can't think of anybody that, let's see. Maybe there's people that have addressed those challenges, but off the top of my head, I can't think of anybody. But there might be people, if I can recall, if I have more time to recall, but don't.
No problem. I appreciate how you do that. I also appreciate how you work diligently in addressing these challenges to our model. It only strengthens our model. So when it comes to the rapid formation of caves and speleothems, if I understood parts of your presentation correctly, you mentioned the recessive stage of the flood, limestone buildup and accumulation. And so caves can be formed during the flood and also post-flood.
Yeah, it can continue into the post-flood period. You could form the opening still, because even after the flood, you still have some water moving in the limestones and sulfuric acid, so it can continue for a while in the post-flood period, but probably wouldn't continue very long. I wouldn't think.
When it comes to the dating of these speleothems, are they dated too early or too young to fit the old Earth paradigm?
They're by the uranium series method. They date up to 500. It dates up to 500,000 years about, and so they date it and they get consistent dates. I would attribute that to accelerated radiometric decay that continued during the Ice Age, is how I would explain that. Get young ages. Of course, that's dating is a whole huge, different issue.
Right. Worthy of its own future presentation, I think.
Many presentations probably. We still have a lot of research to do in that area.
Which gives us endless things to do, that's for sure.
Yes.
And so in relation to your talk then, Here's some interesting questions that have come up. The Creation Bros appreciate the question. Does Mike think that the cave that became full of uranium, known as the Oklo reactor, formed rapidly and during the flood?
I vaguely recall reading articles long ago about the Oklo reactor. I think this is where, I better not say it. My memory's too hazy on that. At this point, I can't see how they'd be connected with caves, but yeah, I just can't answer that question.
No, that's okay. So, in a way, it kind of relates to what you were saying earlier, at least to some extent, with the accelerated decay. So, would your model suggest accelerated decay, obviously during the flood, but then it continues on even into the ice age as well, Mike?
I think yes. I did a study on beryllium-10, and it appears from the ratios of aluminum-26 to beryllium-10 that because that ratio decreases, it appears that the only way you can account for that is by accelerated radiometric decay. So, based on that, I've determined that it continued into the ice age, and I believe Russell Humphreys would go along with me on that.
Right. And Russell Humphreys, he's got Dr. Humphreys has a good list of evidence, as you've actually presented here, Mike, for accelerated decay.
Yes.
Okay, so here's a question that just came in from Tolkien Omics. Appreciate the question. So he's asking, if an underground stream deposits sediments in a 360-degree radius, would superposition fail if that area is filled with new deposits now interjected between layers?
I'm having trouble understanding the question.
Yeah, I don't fully understand it either.
360-degree radius, superposition. I just don't understand the question. Sorry about that.
No, that's okay. If he is still in the chat, Tolkien, feel free to clarify a little bit on the accelerated decay issue, Mike. Just from my own curiosity, because it is such a major issue or talking point today with both skeptics and non-skeptics. If a skeptic were to argue that there is no evidence for accelerated nuclear decay and that it's more of a creationist rescue device, what would be a quick, easy line of evidence or just general response that you could provide a skeptic?
Well, I would point him to Humphrey's research on zircon crystals in granite in a core in New Mexico, where he showed that it had 1.5 billion years of radiometric decay based on uranium changing to lead, but it goes through 18 steps, and it gives off 8 helium nuclei, which grab electrons and become helium nuclei. So it's chock full of helium, way too much to be 1.5 million years. And based on the leak rate, diffusion out of the zircon, you get a date of about 6,000 years. So that's the best of it. It's pretty hardcore. And I know they tried to shoot Humphreys down, but he defends himself pretty good in the scientific literature. So
Yes, he does.
I'd say that's pretty. There's other things that would favor it, but I especially see that as pretty strong evidence that we had accelerated radiometric decay sometime in the past 6,000 years.
Now, would some of that have occurred during the creation or most of it during the flood?
I think we're divided on that. There's surely during the creation, entering the flood, and then tailing off in the ice age, it looks like. So it's not certain. It's just that it happened.
Right.
That we can determine from the zircon crystals.
Yes, I've seen Dr. Humphreys and Dr. Andrew Snelling relatively recently defend both the zircon crystal evidence and radio halos.
Yeah, radio halos is another one, but I don't usually use that one because it's more difficult for the public to understand. So, but the leak rate, the diffusion of the helium, and that one is fairly clear cut and easy to understand.
I'm curious as to your thoughts on this, because I've seen many critics, many non-theists, non-young earth creationists. I think as theists, we believe obviously in miracles and the supernatural. So I don't believe this should be a problem for us. But to skeptics, especially atheists that don't believe in a God in the first place, they'll look to the heat and radiation that is the result of all of that accelerated decay, and they won't just say that it's a challenge. They'll say that it's a preclusionary challenge, as it makes the flood impossible. And so I'm curious what your overall thoughts on that point would be.
Well, I think we do have heat problems with the flood model, and I can't think of any physical way to get rid of the heat. So I go along with Baumgartner, who believes that God, he essentially took care of the heat problem.
Mm-hmm.
So
right. So as creationists, as theists, I find it awkward if an old earth creationist or a theistic evolutionist uses the heat problem argument, because again, they would at least be in the theist camp. And so obviously God was aware of the heat and radiation. He could have dealt with it.
Yeah. So God started the flood. He was in charge of the flood, and he ended the flood. So, he dealt with some of these problems, but I wouldn't bring God into it unless it's absolutely no other way. So that's my position.
I agree. If a skeptic wanted to completely disregard the worldwide flood just because of heat and radiation, aren't they now forced to ignore all of the incredible geological evidence for a worldwide flood? For example, many of the points you've laid out in your presentations.
Mm-hmm. Yes. We do have a lot of geological evidence for the flood, and we have a tremendous amount of evidence for creation. Just look at any organism, the complexity of it, and try to figure out how it formed naturally. I mean, they're all over. There's hundreds of thousands of examples. So we have plenty of evidence. So that's really not a problem. In fact, I'd say we probably have enough evidence for a person to have faith that when we have questions we can't answer, that they do have answers. We just don't know what they are at the moment.
Right. Now, I've got most of your books. There's one behind me. I think you edited it with, it says Ord and Reed on it. And there's a chapter where you describe radio halos and how if there wasn't any way that God dealt with the heat and radiation from the flood, that radio halos wouldn't exist, because they'd be obliterated at extremely high temperatures. And so that could be a good line of evidence for some kind of supernatural supercooling of the rocks at that time. Can you speak to that a little bit, Mike? Is that a position you still hold
to? In that edited book, what's that, 12 or 14 reasons? You can't remember the name of it.
Rock Solid Answers. I just looked behind.
Yeah, Rock Solid Answers. Yeah. And I didn't write that chapter. That was probably done by Snelling. It's an edited book. And to form the halos, especially the orphan halos, polonium, you got to have huge amount of flow because you got to get 10 to the 9th particle in one spot. And I can't quite remember how it goes from there. In order to do that, you got to have rapid flow, and then you got to have it cool down to become solid. And Snelling figured that granites had to solidify in a matter of days. And I'd have to say lava flows like the Columbia River basalts, they had to solidify rapidly also. So that would be added evidence, the halos. Yes, and Snelling goes into that in much more detail and more convincing than I can give right now off the top of my head.
Well, you've done a great job, Mike. I appreciate it. And okay, here's another question that came in. As always with your programs, we have a lot of engagement, both from the critics and non-critics in the chat, Mike. So here's a question from T-Rock. Question for Mike. Are caves associated with other specific geological features such as mountains, rocky formations, etc.?
Well, they're practically all formed in limestone. A few are formed in gypsum, which are your so-called evaporites. You think they're precipitates. And there's even some sandstone caves, which is a totally different dissolving pattern that caused that. I'm doing research on that because there's some impressive sandstone caves. Well, mainly one in Venezuela, one group of caves in Venezuela. So as far as they're in limestone, you find limestone in a lot of different locations. I think 20% of the sedimentary rocks are limestone, which means we had a lot of limestone during the flood. It probably came from the fountains of the Great Deep, and then it precipitated here and there. And but it's not. I don't think it's specifically associated with other features except karst. Karst is a general term for dissolution of limestone in areas like forming of caves, sinkholes, other features due to the dissolving carbon dioxide. That's generally called karst terrain. And but that's just essentially saying carbonates, because a lot of carbonates are karst. And so I don't think it's nothing specific that I can think of is related to the caves. I mean, they are, do see them in mountains, of course, but especially in mountains, because you've uplifted and you can actually see a cliff, you can see a cave. So that's probably the only reason, is because of you can see caves easier in mountainous terrains than you can in rolling hills. Some of the caves in Arizona, one I visited, was essentially on the flats, generally flat terrain. But so that's about all I can say on that.
How much of the world's limestone deposits were from the flood? Nearly all of it?
Yeah, I'd say nearly all of it. Yeah.
Okay. So if a creationist were to say, well, much of the limestone was formed at creation, that wouldn't work?
I don't think so, because the flood was exceedingly erosive.
Right.
If you remember that block diagram, I showed that the average erosion of the top of the sediments was 1,900 meters. We are now determining how much is left. Dr. John Reed, I, and Peter Kleberg, determining how much is left. We're getting around 2,000 meters are left of sediments. So that's it appears that maybe you had about 4,000 meters collect at the peak of the flood on the continents on the average. 4,000 meters. Think of that. That is a tremendous amount of erosion from somewhere and transport.
Right.
And so any pre-flood sediments, limestones or whatever, would probably be totally eroded. There might be some, but at this point, I would imagine that it'd be very rare, and it'd be hard to prove that it's pre-flood also.
Right. Good point. Because I've seen some creationists look to an appearance of age argument to explain a lot of the limestone, stalagmites, stalactites. But as you're showing, that doesn't have to be the case.
Yeah, we don't need that.
Yeah. So in your opinion, all caves would either have formed during the flood or after the flood, with none at creation?
Yes, because limestone is a product of the flood.
Right.
And so, yeah, I believe all caves were formed late in the flood as the mountains came up, and it expanded the sediments, so you'd form your joints, got your cracks in the rocks, and weak bedding plains, and so sulfuric acid would open those things up really rapidly, all late in the flood during the recessive stage, and for a while afterwards, but it quit pretty quick after the flood.
Well, I think that's an excellent answer. That's why we do these programs. So, our fellow brothers and sisters in the world of creation can have these answers ready when skeptics bring up these challenges. Because as you were saying, from plant and animal decay during the flood, we'd have an ample amount of plant and animal deposits. You'd have the widespread occurrence of the sulfuric acid that would rapidly form a lot of these caves.
Yes.
Yeah, I think that's a fantastic answer. And so you mentioned with the limestone, correct me if I'm wrong, in your previous answer, that the fountains of the great deep break open worldwide.
Yeah.
So is it that a lot of the necessary chemicals to rapidly form limestone may have come from the fountains of the great deep breaking open?
Yes, I believe that. I believe we had added a lot of chemicals to the floodwaters from the fountains of the great deep. Limestone being one of them, and I'd say other sediments too, but especially limestone comes to mind.
Very good. Okay, here's a question from Shepard. Can Mike Ord speak about the flood mud rock problem? He says he believes ICR may have done a report on it, but he's not sure. Are you familiar with that issue, Mike?
Is he talking about the sedimentary rock called mud rock? Mud rock is kind of a general term for mud that's been solidified, but it can also be shale or siltstone or claystone. Yeah, we have problems accounting for some features of mud rocks. Yeah, I guess it'd be off topic. We have a problem of dewatering mud rock. That was showcased in the latest Creation Research Society Quarterly. So yes, that's one of our problem areas, dewatering mud rock. That's probably what he's referring to. I don't know if ICR did the report. But it's in the latest CRSQ. So it's a challenge. A lot of us are thinking about it, but at this point, I don't think we have an answer to it. So that's another challenge. Like I say, I find a couple of hundreds of them. A lot of them seem easy. Give us some time. Others seem almost impossible. But I have worked on some ones that seemed almost impossible and found solutions. So just because it seems impossible doesn't mean it is impossible.
Right. Well, and as you said in your presentation early on, it's important that as creationists, we find more people who are passionate about the topic and they get into the research, and we have more scientists and thinking minds on it.
Yes.
And so you briefly mentioned, if I'm not mistaken, this challenge in one of your opening slides. And I'm curious to hear you speak to it a bit, because it's another major challenge that's frequently brought up, and it has to do with the desert dunes and other desert deposits that they argue. I think they look to certain features in the Grand Canyon, and they'll say that these desert deposits can't form under intense floodwaters. They basically need, I think they say, lots of time in dry land. So I guess what would be a good response to something like that?
You can go on the Answers Research Journal website, and you can find several articles on that. One done by John Whitmore, who's the lead author, on the Coconino sandstone. First of all, he discovered that the secular scientists hadn't done very good research on that to claim that it's a windblown sediment. Analysis of it said it had feldspar and mica, which you're hard pressed to, especially mica, form that in a desert. And the cross beds, they're pretty large. Maybe we'll say 20 or 30 meters high, a cross bed like this. And that shows you the current direction is going like this, because it's moving like that, and it's for kind of a delta structure that moves along. And if it was a desert, the angle of repose is about 33 degrees. But often these, like in the Coconino sandstone, are around 22 degrees on average. And that's what you expect by ones deposited in water. And it's because of the huge cross beds that secular science has even suggested that they're deposited by wind, because it seemed too catastrophic for them, and it would be. But we've since seen underwater dunes that are of that scale, by the way, in spots. So, and by the way, the grains are not well rounded either, as you expect in a lot of deserts. Deserts will round a coarse grained sand pretty fast, but the grains in the Coconino sandstone are generally subangular to subrounded, which means that more likely it's formed in a watery environment and not in a wind environment. And you can say this for a lot of the sandstones in the West. The Navajo sandstone you see in Zion National Park, you see 2,000 feet of almost pure sand. That's a pretty tall order for a desert. But anyway, we've done research on this, and I think we got a pretty convincing case that these were deposited in water and not by wind.
And you mentioned micas. Is that a type of mineral or a group of minerals?
It's a platy mineral, and with wind you would destroy it.
Okay,
that's the issue.
and so that was right there would be an observation that's consistent with underwater formation. Yeah,
you can form that underwater better than you can in wind. And there's several others. Look on the answers. The person that really wants to do their homework. They're big articles, by the way. Mm-hmm. You can go on the Answers Research Journal, and you can find John Whitmore has several articles, but there's one main one about 8 years ago, I think, 10 years ago maybe, on the Coconino sandstone. He's done huge amount of research on sandstones and sands, so I'd say he's quite an authority on it. So the person that really wants to dig and find out our answer, the answers are there if you want to look.
Are deserts in general readily explainable through the young earth creation position?
Yeah, I think so. First of all, there's a problem accounting for so much sand. But during the flood, you'd expect the last bit of runoff to leave mud or sand or a combination. And then the wind will rework it into sand dunes or silt areas called loess, Loess. And you have a lot of this material on the surface of the earth. And it's difficult to explain by present processes. That there's way too much. It's difficult to figure the source, but our source would be the leftover deposits at the last draining of the floodwaters, and that these were reworked by ice age winds into sand dunes and areas of loess. Loess covers 6% of all the continents, especially south of the ice sheets in Europe and in North America. And some of that stuff is 50 meters thick in spots. So, and you'd have a lot of wind late in the ice age, especially at the boundaries. So you'd expect a lot of this material. But where it originated, they haven't the problem. And here's another problem. They find that most of this loess is from the last ice age. And the guy wrote an article called "The Missing Loess." In other words, you don't see the loess deposits from previous supposed ice ages, in which there's now 50 ice ages during the Pleistocene of various intensities. And you don't see much of those. But now, because this guy pointed this out in the journal Earth Science Review, I think in 2007, Van Loon was his name. I think now they're redating some of those lower loess layers, and they're getting some from previous ice ages, but the overall volume of that material is a lot less than what the current. There's no way you can account for the loess being deposited in the last ice age and not in any previous ice ages. They have ideas of it eroding away and then coming back. But I mean, we have such thick loess layers right now that the next ice age is supposedly due soon, according to the Milankovitch mechanism, and we still have it all there. It's not disappeared or been reworked. So that's one of their problems. And it was admitted in the journal Earth Science Reviews 2007 by a man named Van Loon, called "Missing Loess." I wrote an article. You can read about it on the creation.com website.
With the explanation involving leftover deposits from the late stages of the flood, and then those deposits being reworked post-flood, specifically during the ice age, if I understood correctly. So all deserts would be formed post-flood and not pre-flood or at creation.
Correct. Because you had so much erosion from somewhere, and that there'd be anything from the pre-flood you're not going to find.
Right.
So because of all the erosion of the pre-flood world.
I think this is so important because many people may erroneously think that most of the earth that we see today, including deserts, a lot of the geological features, reflect the pre-flood world or even the creation week, when in fact much of it has been reworked because of the flood. The entire real estate's essentially been rearranged. Is that right, Mike?
Exactly. We don't really know the pre-flood geography or topography. There's a number of questions about the pre-flood world, but we have clues in the Bible. We have some clues in the rocks and then fossils. I even have a whole chapter on that topic in my book I wrote with John Reed, How Noah's Flood Shaped Our Earth. I have a whole chapter on what do we know about the pre-flood world. And we do know some things, but a lot of things we don't know.
I can't remember the exact verse, but I think it's in Job. I've seen some people look to Job. He talks about ice or frost, perhaps, and they
Yeah,
say that he may have seen the effects of the post-flood ice age. Do you believe that that's the case, or?
it's possible. I don't think it's you can die on that hill.
Mm.
Um,
Right.
he described features that could be seen in winter, but some of the language kind of indicates it was more than that. Like a lot of ice, and forgot the exact wording, but so I think it's a good possibility that he was witnessing features of the ice age, but we can't be dogmatic about it.
Right.
That was the case.
There's just not enough there to be dogmatic. We can
Yeah.
speculate, but I think this may be at least one of the articles you're referring to, Coconino's Sandstone, Dr.
Yes.
John Whitmore.
Yep.
So people feel free to take a deep dive there. And I had a good question here from I don't think we did this one yet. Shepherd. Could caves be recreated without openings? Then as floodwaters receded, openings were created?
Recreated. Let's see. The last part seems as floodwaters receded, openings would be created then because this limestone is uplifted and you expand it, and the expansion causes expansion cracks. So you have a lot of cracks, joints, they call them. A lot of times they're perpendicular to each other, and so yeah, and then you have still a lot of water in there that has to dewater, and as it's running through especially the cracks, it'll widen the cracks, and weak bedding planes, it'll sulfuric acid would eat out those bedding planes and form a horizontal chamber. And there's a lot of evidence of catastrophic flows in caves, like big boulders and stuff like that in caves. Yeah, and the first part, I
I
don't
think
understand the first part.
I think Shepard may have clarified in the chat that he didn't mean to say recreated. He just wanted it to be created. So could caves be created without openings?
Well, by definition, a cave is an opening. So, no, I don't think so. I think that the sulfuric acid in the floodwaters will form these openings pretty fast as the waters recede and the continents come up relative to the ocean basin sinking.
This one's kind of off topic, just came to my mind because of how involved I am. I do this full time, so I see a lot of what the discussions are taking place, and I see creationists debating what can be the result of apparent age and what can't be. And I think, as you've demonstrated, caves, stalactites, stalagmites, limestone, we don't need an apparent age argument for these features, these realities. Another one has to do with the craters on the moon. So some say there's just too many craters on the moon to be explained in a young Earth creation timescale. And so the moon must have been created with those craters rather than occurring after creation. What are your overall thoughts on that, Mike, if you had any?
Oh, I can say a lot because I've worked on impacts.
Right.
Being either a cause of the flood or part of catastrophic plate tectonics. And I've come to believe, based on my study on floods of Mars, that I've come to believe the day 4 cratering hypothesis by Danny Faulkner, which says that at creation, the earth was formed before day 4. But on day 4, God created all the other bodies of the solar system and the stars, the sun and the moon. And in the process of creating, he created out of mass that he made on day 1. And so he put the mass in the planets. And part of that was for planetesimals to still be moving around for a while and impacting the surface from day 4 onward. And so I come to believe on that. Then he believed that the big basalt areas on the moon were from the flood. I've studied Mars and written 3 papers now for the Creation Research Society Quarterly, and study the craters. I can show that the big ones formed later than a lot of the small ones, because Mars had a magnetic field, and it magnetized the crust. And when an impact hits the crust that's magnetized, it destroys the magnetism. But the magnetic field is still there. It will it'll reform in the melt rock. But if the magnetic field is gone, or it won't reform. And so you have a lot of craters where you have the magnetic field that isn't affected by the cratering. But then you have some of the large ones where the magnetism was destroyed and never came back, which means it came later than the rest of the craters. Same as on the moon. So you had craters formed during creation week, day 4 cratering hypothesis, and then you had craters formed during the flood. So two cratering events. And I have a long article, over 20,000 words, that I'm going to publish on my website as soon as I get my website refurbished, and probably late summer to early fall. And I'll have a free article on impacts being a model or a submodel of the flood. And I'll talk about the day 4 cratering hypothesis and all the evidence and for that from Mars, and that applies to the moon. But we don't find these craters on the Earth because the Earth was formed before day 4, you see. And so we escaped. And so it didn't destroy any of the organisms that God had just was creating during creation week. So that's how I would explain that. And I think I have a fair amount of evidence. And I also explain the floods on Mars too, by the way.
Well, you have a whole presentation on that too, don't you?
I do. Have I given it to you before?
No, that might have to be our next one, Mike, because that sounds...
Okay, I can do that.
Let's do it right now. No, I'm just kidding.
I gave you kind of a quickie on one part of it.
Right. Sneak preview. So if I understood you correctly, and if I remember correctly too, the secularists say there's maybe a million or so craters on the moon, with at least 1,000 of them just miles and miles wide, 12 miles, I think. So those are some big craters. But you said a lot of those larger ones would be formed later, after creation, with a lot of the smaller ones during creation week?
Yes.
Okay.
That's the day 4 cratering hypothesis. And so you get a lot of the... you only have maybe about a couple thousand of over 20 kilometers in diameter or something like that. Others are pretty small, and they can form by secondary craters when one big crater forms, it blasts up all these rocks, and they come
Oh,
back
right.
down forming craters. And so you usually have 1,000,000 times as many small craters, a kilometer in diameter, maybe on that order, formed. So a lot of them can be from that mechanism of the secondary craters.
That's a great point I had not thought of. So when they say there's 1,000,000 craters, with only 1,000 to 2,000 being really large, a
Yeah.
large one could hit, but then pieces of rocks fly up, come back down, and make more craters.
Yes. The
Okay.
smaller ones.
Okay. So many craters can be due to one large one.
Yes.
Okay. Well, that lessens the problem or the challenge a little bit more. That's a great point. Okay. Well, I look forward to you putting out an article on that in your website. I'm just trying to almost think what someone might object to that. What if somebody said that the craters, a lot of them being formed during creation week, that would go against a very good creation?
Yeah, I used that against Faulkner when I didn't believe his mechanisms.
Oh,
And he says, well, no, not necessarily. It might be violent, but it doesn't mean it's not against a very good creation. So he had a good point, and
mm-hmm.
he persuaded me
Yeah.
that there's no biology on those
There's no killing going on, right?
Yeah, so there's
Could that
really, yeah.
could that have been a way for God to make the moon look a little more appealing, have a little more personality to it, rather than just being this big clear rock in the sky? I'm not sure if it's happening
I'm
at creation
sure
week,
that
right?
there's a lot of spiritual reasons for a lot of this, but I'm not very philosophically or theologically minded, so a lot of this escapes me. My wife would be a lot better at it to figuring these things out than me.
But you're dealing with the science really good. I think we'll turn that last segment into a clip, since that's a topic that has invoked a lot of discussion lately. So I appreciate that, Mike. Okay, this one comes in from Sandy C. Thank you for the question. Question for Mike. Considering that carbonic acid is neutralized as it sinks, what other ways of stalactite formation do evolutionists propose?
Well, when it's neutralized, it can't excavate caves. It can't excavate the opening. That's the point. But then, as it's coming down and it drips into the cave, it's neutral. It's neutral. But when you degas the CO2, the reaction goes to where it plasters calcium carbonate onto the speleothem. So it's two different ways of thinking about it. That's pretty standard as far as forming speleothems. But as far as the cave opening, that's where they have the real problem, forming the original cave opening, because the acid it's neutralized. I hope
Very
that
good.
answers the question.
So even when it comes to cave formation and stalactites, stalagmites, so on and so forth, when evolutionists propose that as a challenge to us, there are also challenges to them, even existing within that challenge.
Oh yeah, right. I gave several of them. One of them being that in their mechanism, it's very difficult to form an opening out there because the acid's neutralized, and once it's neutralized, it's not going to react to the calcium carbon or the limestone anymore.
Right.
So, yeah, major problem. I wonder how many of them have thought seriously about it.
Well, and that's what I appreciate about you, is you are thinking very seriously. You're diligent about our apparent problems or challenges, which you oftentimes find easy answers or sometimes more difficult answers, I guess you could say. And so does that all come down to model building rather than just always or only attacking evolution and uniformitarianism, or I think they call it actualism now. We're
Yeah.
actually building our own model.
Oh yeah. I spent much of my 50 years answering their challenges, and not necessarily challenging evolution, which I find extremely easy to do. Once in a while, I'll give a talk on it, but I hardly ever talk about that. I usually only talk about how we explain things, ice age, uh, features in geology from the flood. So I spend most of my time dealing with building our model and giving our explanation.
On that, the Ice Age, there's some comments and discussion in the chat on the biblical timeline from the flood to the Ice Age, and then the no longer an Ice Age, I guess you could say. And so someone in the chat is wondering if Abraham would have been alive during the Ice Age.
I believe so, yes. But he lived in the Middle East, where the climate there during the Ice Age would be quite ideal. With cooler summers and warmer and milder winters, it wouldn't be exceedingly hot. It'd have a lot more precipitation. It'd be a great area to live. And maybe that's why when Abraham and Lot were looking down the Jordan Valley, they noticed it was well watered everywhere. That could be a result of the Ice Age, that with the higher precipitation and milder summer temperatures, cooler summer temperatures, and mild winters. So it'd be kind of an ideal climate during the Ice Age to live in that area. So yeah, he did live during the Ice Age, because the Ice Age was about 700 years long, and Abraham lived about 400 years after the flood, something of that order.
Okay, so the post-flood or the Ice Age, about 700 years. How long after the flood, with the effects of the flood that you talked about in your presentation, until we were in an Ice Age, do you think?
Oh, right away.
Okay, right away.
But you have to remember, the ice didn't form where it occurred all at once. It would form first in favorable areas like central and southeast Canada. You have west-east winds, and so you got to be away from the warm onshore flow from the warm oceans and close to the storm tracks. And so central Canada and southeast Canada would be kind of seed areas for the early developing of the Ice Age. And the high mountains would start snow on them right away, and everything would grow from there to when you reach glacial maximum, about 500 years, then it melts in 200 years. So it started right away, but starting in seed areas. In Europe, it probably started in Northeast Europe, Scandinavia, Finland area, northern Russia to start with as seed areas, and just grew from those seed areas.
So rather than, I've heard some creationists say that the Ice Age and the flood happened together, simultaneous. But you're saying it was more so the result of the flood, and it accumulated slowly.
Yes.
Right after the flood. Okay.
See, the flood had warm water and no land. It was so you can't form an Ice Age during the flood just by a number of reasons. So, but you can afterwards because of the effects of the warm water and all the volcanic aerosols in the stratosphere from the flood, and reinforced from post-flood volcanism that reflect sunlight back to space. That cools the continents. The warm water provides the massive evaporation you need for the Ice Age.
Yes, that's very good. So a really popular, as you may know, group of movie franchise is the Ice Age. There's a whole bunch of them. The kids love it, and just kids in general. But obviously, there's a lot of propaganda in it, right? And you see a lot of the same types of animals with mammoths, saber-toothed tigers, sloths. And so these animals that are oftentimes depicted in these Ice Age films or Ice Age documentaries, from our specific model or viewpoint, those creatures would have come about through adaptations at some point during that 700-year period, Mike?
Yeah. I like the mammoths. As I in the book, one of my books.
Yeah. Is that Frozen in Time?
Yeah, Frozen in Time.
Yeah, I've got that one.
I must be getting tired. My brain is kind of going slow.
You're doing good, Mike.
I believe that took 2 elephant types on the ark, and from those elephants, after the flood, they differentiated by the genes already built in, all the variety already built in. They differentiated into the elephants we see today and other types of Ice Age elephant, like the straight-tusked elephant, and also into mammoths and mastodons.
Mm-hmm.
And it'd be slow to start with because they reproduce maybe every 10 years. And so, but then you get a number of them, and then it mushrooms. In fact, I did a timeline, and within 300 years, if none of them died, you'd have 1 billion or more mammoths on the earth. So by geometric progression, once it gets started and they differentiate first, the populations of mammoths would mushroom. And there's a variety of mammoths, but they're all can interbreed. They found out that the Columbian mammoth and the woolly mammoth, they could interbreed because you find gradations between the two as fossils. And so, but at the end of the Ice Age, like I said, 2/3 of these mammals weighing over 100 pounds went extinct globally. And you mentioned some of them, the woolly mammoth, the saber-toothed tiger, sloths, but a lot of other animals, even in Australia and South America, some of those big beasties, they disappeared too at the end of the Ice Age, because the Ice Age was like I've shown, it was colder than today, windier than today, drier than today. So you have drought, big windstorms. You have a lot of features that cause animals that weren't used to the cold go extinct. So it all fits into a nice pattern, I found.
It does. I agree. And you and I, we've discussed in previous shows, which I think is a counter to an evolutionary objection, that if a lot of these genes are front-loaded or pre-existing for these kinds of rapid adaptive episodes in, let's say, elephants to mammoths, then these changes can come about quickly within that 700-year time span.
Oh, yeah, right. Mm-hmm. Yeah.
Because it's the evolutionist that assumes all of this DNA diversity and DNA differences are the result of mutations. But I think you and I would agree that the majority of it is probably the result of design diversity.
Yeah, right, exactly.
Okay, very good, Mike. I think we're doing well because we may only have one, just double check. I think we only have 1 or 2 last questions here. This one from Pickled Grammar on the Ice Age here. How lower would the sea level be at the peak of the Ice Age?
Good question. It depends on how much snow and ice collected on the continents. Because as you collect the snow and ice on the continents, it comes from the ocean and that sea level falls. I've calculated, and it's published on Journal of Creation. You can get the articles on creation.com on evidence that the Laurentide ice sheet was thinner than they think, and the Scandinavian and the British-Irish ice sheets were thin. I've calculated roughly that we would only collect 40% of the ice they claim. So we don't have 3 to 4 kilometers of ice in like central Canada. So with 40% of the ice that they claim, and they claim sea level went down to 120 meters below sea level, that means our sea level would be down to about 50 meters below sea level. And so some creation scientists haven't really caught on to that and have used the secular figures, and they shouldn't be using those because the ice age caused by the flood was a fair amount thinner than they claim. 40%. It'd be 40% of their ice, which means sea level only dropped about 50 to 55 meters below today's level at the peak of the ice age.
Is the result of the ice age the sea level being lower because you're throwing all that water into the ice caps?
Yeah.
Is that largely when when we look to biogeography, where a lot of the animals are positioned around the globe, like the marsupials in Australia, and so is that they became trapped there? Is this a good explanation from a creationist position?
Oh yeah, biogeography. It's a field that really caught my interest lately. I've even written some papers on in the journal Creation. One on how to explain the marsupials.
Mm-hmm.
I think we have more ways of animals spreading from repopulating the earth than the secular scientists. For instance, we have huge log mats that would still be floating around after the flood. And these would be so huge, they'd probably be pretty thick. They might be 100 miles wide. I mean, left over from the flood, and they'd float for maybe up to maybe a few hundred years. And with these, you can spread organisms globally with these log mats. I think that's part of how the marsupials got to Australia. And I think it accounts for other anomalous features. Biogeography has a huge amount of anomalies that both uniformitarian and creation scientists need to explain. So I'm right now reading about it. I think I've published one or two papers on this subject already. And so, and I have one that's going to come out on the unique fauna of Madagascar. So I'm getting into it. And I think we have potential to explain the many, many, many mysteries out there when you look at the present distribution of animals.
Is it? Well, firstly, I look forward to those technical articles. That's for sure. You and I, we've done a whole series on all the boundaries, pre-flood boundary,
Yes,
the flood boundary, and we would hold to a higher flood boundary. Is it?
Yes, I would, and I think most creation scientists would now lean that it's in the late Cenozoic. Tim Clary is one advocate of it, and I got on my website, you can get 33 evidences for why it's in the late Cenozoic. Some of these are very powerful pieces of evidence, and a lot of them people haven't thought of. But one of the strongest evidence is coal. You know, coal, there's a lot of Cenozoic coal clear into the Miocene. And to form coal, you gotta, it has to be during the flood somehow, but you can't conceive of it being after the flood because you have to rip up this vegetation, pile it up in huge masses with no other sediments within it. Then you got to add thousands of meters of sediment on top of it to press it down, heat it up, and form coal. And then if it's found at the surface, all these sediments that were above it got eroded away. I mean, this is an obvious flood mechanism, and the fact that you have coal, a lot of coal in the early Cenozoic, but you have a lot of coal also in the late Cenozoic, and so the fact that it's there, even to the late Cenozoic, means the post-flood boundary has to be above those areas. So that put it generally near the Pliocene, Pleistocene. Even though I don't take that, that's a secular boundary, and I think those, especially the Cenozoic, are rather arbitrary, and they change with time. And so I take every place has to be use its own evidence for it, but in general, I say late Cenozoic, which could be Miocene, Pliocene, and even in the Pleistocene. The Pleistocene is no magic number for the Ice Age. There are thousands of feet of Pleistocene sediments in places that, to me, can't be deposited after the flood. And so this is just another time slot. So in some places, I think the post-flood boundary is in the early Pleistocene, sometimes in the mid-Pleistocene in some areas. Other places, I think that for the Australian marsupials, I actually put it in the late Oligocene, because when I just examined this, I found out that their dating systems were atrocious for those marsupials. When they first found them as fossils, they dated them as Pleistocene, which you'd expect. I mean, yeah. But then because they saw primitive features, I put that in quotes, based on the stage of evolution, some they thought were older. And so they got pushed down to the Pliocene, then the Miocene, and finally they've settled in the late Oligocene, based on the stage of evolution and primitive and advanced features, which is, to me, all arbitrary and circular reasoning. And so for those locations where you have marsupial fossils, I would say the boundary would be in the late Oligocene, and those spots. And they hardly ever date these by radiometric dating, especially in the old days. But now they've been able to do some of that. In fact, you can read all about this in the Journal of Creation. It's probably on their website, creation.com. The explanation of the marsupials, which I've given you a good summary of it.
Well, and you've given us good answers in the comprehensive series that we've done. I think a couple of them were 3 hours each. And so you would say late Cenozoic, but variable.
Variable,
so it's not
exactly.
like this real strict cutoff point.
Yeah, I don't have a strict cutoff line, because those cutoff lines are assuming the secular system, which is rather arbitrary in the first place.
And being variable, late Cenozoic and variable, does that come in handy in answering the biogeography that some who hold to a lower flood boundary would argue is easier to explain from their position?
Yeah, it could. I'm mostly thinking about the present distribution. That you don't have to worry about fossils, but with time, I'd have to think about where the boundary is and what would be the post-flood fossils in this. And so this is the thing. Research, you go into more questions. So dealing with the boundaries, I've gotten into biogeography now. And
you answer one challenge and then 10 new questions or challenges are raised.
Yeah.
I think your argument, which is just one of many, 30 plus, on the coal beds, some of them are 75 meters thick, you've said.
Yes.
And they would have to be heated up significantly and then be buried in many kilometers worth of sediments.
Yes.
So I wonder how that could happen post-flood. That seems like a flood signature. Especially the heat.
How can that happen post-flood? And most mountain uplifts occurred in the late Cenozoic. I mean, in Wyoming, I can make a case that we had 45,000 feet of differential vertical tectonics, where the mountains rose, the valleys sank down. Mm-hmm. And that would have happened during the Cenozoic. So much stuff happened during that. Just look at the history of the Cenozoic, even from the secular point of view, and try to put that after the flood. It doesn't fit. But there are several creationists that see, and you might have had them on your program already, that based on the fossils, they put the boundary way down by the Cretaceous Paleogene, but there's problems explaining fossils with a high boundary. So I admit that, and so it's a subject of research, and I haven't figured it out yet. But when I had 33 other reasons, and And you got to have multiple reasons, evidences, because some of these are equivocal.
Right.
Like one of my criterion was permineralization. The flood would be a great mechanism to fossilize, that is, pre-mineralize the fossils, but the flood, you wouldn't have that. And so that would be one criterion. But there's exceptions. There's enough exceptions, like soft tissues in dinosaurs. So, and yet you'd probably find some ice age sediments, animals that are actually permineralized. So there's enough exceptions to say that, well, it's an indication, but you need other criteria. And that's why you need multiple criteria. And I've developed 33. I might add that Tim Clary has reinforced some of the ones I developed and added 2 more. So we have about 35 criteria. And if we spent more time, I'm sure we can get up to about 50. It's
Wow.
just that these are the ones that we can easily get out and research and think about. But I haven't thought real deep on other ones yet. So I'm sure I can find another 15 or so.
Well, that's awesome. I think one that you and Tim Clary have both put forth is late in the Cenozoic. You're talking earlier about these mountains that are going up 40,000 feet. So that would be catastrophism right there with the tectonic movement.
Yeah,
and those are above the KT boundary. So how can the flood boundary be the KT flood boundary if we have these flood signatures above and beyond it?
Yes, that's right. You have, during the Cenozoic, you had huge tectonics. Practically all the mountains we see in the world rose in the Cenozoic. And I mean, you expect that in the flood, but not after the flood.
So would a lower flood boundary proponent say that they started to uplift before the KT, but then rapidly uplifted after in the late Cenozoic? I'm just trying to wrap my head around.
They would say that. You don't find a lot of evidence of uplift in the Mesozoic. You find it practically all in the Cenozoic. So, but they might say it could have started in the Mesozoic before the KT boundary or the KPG boundary. Yeah, they could say that, but the majority of it, the vast majority of it, occurred in the Cenozoic.
Right.
I mean, there's a lot of other things, like you have a huge amount of volcanic areas in the Cenozoic. And with all that volcanism, you'd have volcanic winter.
Right.
And so you'd have trouble accounting for the warm climate in the that they claim occurred before the flood and after, between the flood and the ice age, to fit in the Cenozoic, which shows predominantly warm climate vegetation. Also, you had some impacts during the Cenozoic, and at the KT, you had that Chicxulub impact, and that would have put all these particles up in the stratosphere and caused a massive impact winter. So you'd have cold temperatures caused by just these two. These are 2 of my criterion: volcanism, Cenozoic volcanisms, and Cenozoic impacts. So I just gave you a few of them, but there's a bunch of them, and it's just overwhelming to me, that, and pretty positive for someone that wants to investigate it, that the flood post-flood boundaries in the late Cenozoic, but variable.
Overwhelming, I agree. Late Cenozoic or Cenozoic volcanism, flood signature, and Cenozoic meteor impacts.
Yes, even the one at the KPG would. There's been several articles saying that they would cool the Earth for down about 25 degrees centigrade or Fahrenheit for about 10 years. So how would that fit in after the flood? So, it fits in with the flood very well, but not after the flood. And there's other Cenozoic impacts that occurred that would be smaller than the Chicxulub impact.
Right, I agree. And so would somebody who holds to a lower flood boundary, would they be forced to argue that there are no mammals, including whales, in flood deposits?
Yes, that's another one of the criterion in that you hardly had any mammals die in the flood and be deposited in the flood, but you had millions, tens of millions of them in the Cenozoic that spread all over the earth, died and were buried and fossilized after the flood. So
Right.
yeah, that's another criterion. Another one is the order that they claim in the Cenozoic with the mammals, where they originate suddenly and then they die out at a certain time. And there's hundreds of these things that over the earth, they originated same time globally, died out at the same time. So that's the second criterion, the order of the mammals in the Cenozoic. And of the whales, of course, that'd be there's been some crazy things said about that, and so anyway, I think I've listed 6 of the criterion that I use. So I did pretty powerful pieces of evidence, and
Mm-hmm.
that it's in the late Cenozoic, the boundary.
Well, we have a clip uploaded on the channel, and I think the website, because on my website I have a whole section people can go to titled Flood Boundaries, and your whole series that you've done with us is there for people to see.
Good.
And that comprises your 33 criteria. And so based on your answer there, when a critic says to us as a young earth creationist, oh, why don't you find whales in flood deposits? That's kind of interesting. No whales that are marine animals or creatures in the flood, but that would only be an objection to someone who holds to a lower flood boundary then. Is that
Right,
right,
exactly.
Mike? Okay. Okay, very good. Well, I think we'll wrap it up with this then. George Bond, who has interviewed you with me several times, he says a very special hello to Michael.
Hi,
J.
George.
Ord, one of my favorites. Yes. I always look forward to these with you, Mike, because you're a wealth of information. You're an encyclopedia of information. I love just bouncing ideas off of you, asking technical questions that come to mind. And so it's always very helpful, especially on these technical topics like the rapid formation of caves and speleothems, or
Yep.
last month, ice cores. And so I like leaving no stone unturned. And you're a true blessing when it comes to that, Mike.
No, you're welcome.
Okay, brother. Well, there we go. 2 hours has flown by. To the audience, I appreciate all the engagement. Lots of excellent questions, thought-provoking questions with some great answers. Mike, I also appreciate you engaging the impact craters on the moon question. So any final words and final thoughts from you before we wrap things up?
Oh, let's see. Well, I appeal to the skeptics to examine all the data. That's what I say for people that get into environmental issue, global warming. Look at all the raw data first before you jump to conclusions. A lot of times you'll find a different narrative comes out of it than what you often hear. So I'd like to leave that for not only skeptics, but also creation scientists. We need to do that too.
Amen. And I think you've demonstrated sufficiently tonight that many of these observations, many of these geological features that we see on the planet, we don't have to explain them through apparent age or appearance of age. We have explanations just through flood mechanisms.
Yeah,
as you
and I see.
demonstrated.
Yep.
Okay, brother. But we got lots of great feedback from the chat. People saying they were edified, they enjoyed this. Shepherd
Good,
here,
you're
yeah. Shepherd here, appreciate the support. Says I came to learn. I have. Thanks and blessings to all. That's why we do these. So
Yeah.
share these around to your friends and family. Mike, again, I appreciate your time. I know how busy you are. And okay, God bless you, Mike, and God bless the audience.
Yeah.